Cloud computing is everywhere now. Not only individual users, but also larger scale businesses outsource their data to the cloud servers for better availability and scalability. However, a privacy issue appears when outsourcing. In some cases, the user has particularly sensitive data, like medical records of patients. In that case, the user can encrypt the data before storing it onto the server. But would that be enough? Unfortunately not. With encryption, the data content will be protected, but the access pattern, meaning the sequence of accesses to the encrypted data, can leak sensitive information. Imagine an adversary finding out what kind of disease you might have by observing the pattern of a doctor accessing your encrypted medical record. For hiding the access pattern, recent studies tell us to use ORAM. That is an expensive protocol. It keeps data items randomly shuffled around the storage. And then when the user wants to access a single data item, ORAM translates it to many accesses to data items from different locations. ORAM gives us provable access pattern privacy. So in theory, it is a solution. But we live in the real world where ORAM overhead is impractical. If I tell you with ORAM, out of 100 gigabytes of the space, you can only use 20 gigabytes of it, and the access will be much slower, would you take it? Probably not. This is where my research comes into the picture. In my thesis, I aim to bridge the gap between the efficiency and the security. To do so, I identify the source of inefficiencies when adopting ORAM protocol at the system level, where the processor interacts with the memory. I introduce lightweight architectural components as well as modifications to protocol functions in order to improve ORAM efficiency so that it requires less space and becomes faster. In the end, remember, privacy is not only about the content, but also the access pattern. And protecting the access pattern may be too expensive today, but hopefully not so much tomorrow.